go over number one now. So this is question number one, and then I have it graphed, the equation that they gave us. We had to look at the graph, and then you guys went through, hopefully using your graphing calculator, and you found that 6 was a 0. And then from that 0, you were used synthetic division to take it out. And you probably found negative 2.5. But as I've described earlier, we don't want decimal or fraction factors. So that one you can see I've changed into 2x plus 5. And then once you've taken those out, the other two are irrational. So you had to use quadratic formula to find the other two. Okay. And I have it two different ways that the majority of the people had. And then actually some of you separated it and wrote 5/4 and square root 17/4, which is the same as the way that I wrote it. But I had talked about not having fractions, so that's why some people did it like number 3 as well. Either way, I'm going to turn both of these on. Either way that I do it, and now I have it zoomed way far out as well. Like this is up to 75. This is down to 195. So I have it zoomed far out so we can see how this compares to my factored answers. So here's question, the one that a lot of people had, where you just did the quadratic formula and put those answers with the x. And then here's the way that I did it, where I got rid of the fractions, and you can see that none of them are the same. Okay. And if I click on the x-intercepts, they do all have the same x-intercepts. So like that question that I was talking about before I started recording with the line, that question that I was talking about, what's the difference between all three of these? They all have the same general shape, but what's the difference between all three of these? And I don't mean like subtract two numbers, like how are they different? There's a stretch or a shrink. The black one's the original one. The red one's kind of shrunk vertically. And then the blue one is really stretched. And that has to do with the fact that when I'm going to turn these off and I'm going to go back to that line question that I had. When you find a 0, if you're only looking at the graph, all you know is the 0. You don't know what's originally graphed. So if I had 2, if I had 2x plus 4, if I had a stretch on that, all I would know is that the original question was x plus 4. I would have no idea there was a 2 in front unless I multiplied it back together. So what we have to do is we have to look at our answers, our factored form, and we have to compare those to the original. We have to look at our factored form. We have to compare it to the original. I'm going to write this on a Cami file so you can see it, since it's, maybe I'll cheat a little bit. I'm going to copy and paste it. There we go. I'm going to put it on a Cami file so that you can see what I'm talking about. Okay, so this was the original. We know for sure that is the right question. That's the right graph because this is what was given to us. So that one we know is correct. The second one, a lot of you got. The third one, probably some people got, like I got the third one. But if I were to multiply all of this back together, I should get the original. Now, I'm not going to multiply it all back together. What I'm going to do is I'm just going to think about if I multiplied the first terms back together, it should equal the first term. So what happens if I multiply x times 2x times x times x? What do I get for my first term for this one? Nico, what do I get if I multiply together x, 2x, x, and x? This is all I heard you say, sorry. To the fourth, yeah. Is that the same as a 4x to the fourth? No, it's not. That's why it didn't look the same. And if I did it to this one here, if I multiplied out x and 2x and 4x and 4x, Evan, what would I get? Okay, so again, not the same as 4x to the fourth. What would I have to do to 2x to the fourth to make it into 4x to the fourth? Multiply it by 2. Let's see if that works on the graph. So that was this one. What if I put a 2? Oh, I got to turn it back on. Hold on a second. Turn those off. Go back to my zoomed out window for a second here. It was like, what did I do? 2. That's what I had. So if I were to use this equation and put a, what did we say, a 2? If we were to put a stretch of a 2 in there, look, now it's exactly the same. So there's this extra step that I did mention it, but we didn't. I knew that you guys would forget about it because everybody forgets about it every single year. So I like to go over this together. So let's look at the other one. What would I have to do to 32? What would I have to do to 32 to change it into 4x to the fourth? What would I have to do to 32 x to the fourth to change it into 4x to the fourth? Multiply by 1/8. Who said that? Chris, good. So I'll go ahead and put that 1/8 in front and see if that works. Oh, I don't have it turned on. Come on. There's that equation. And then if I put the 1/8 in front, that's perfect. Okay. So what you're going to have when you do these is you're going to have this tiny little extra step because you can't tell if there's a stretch on it when you're just looking at x-intercepts. You can't tell. So you should check your first terms before you decide you're done. You should check all your first terms, multiply them back together. And if they do not equal this, add in a stretch or a shrink or a reflection. Could be a reflection also. And also, if you have time, graph them both. You know, after you put that stretch or shrink in, you can graph them both. When we have this on a quiz or a test, you will have your calculator. So you can check your answers. Shouldn't get them wrong unless you just don't know what you're doing. Okay? So take some time. I want you to go through and start graphing both of these. I want you to figure out if you're missing any stretches or shrinks, or maybe you just totally got them wrong. And I'm going to come around and help you. And then the second half of class, we're going to learn the second half of section 2.5 notes. Okay?